And so the next question, how do we handle updates or maintenance on the satellites once they are in orbit?
You can get one at spaceladder.com. No, I mean, that's one of the big challenges is once they're up there, they're up there. We can do software updates. We do regular maintenance from the software and operational side. But once the satellites are launched, they're up there.
Hello, everyone, and welcome to today's AMA session. I'm Stuart Gardner. I'm the CEO of Spacecoin, and I'll be your host for today. And today I have the great pleasure of chatting with my colleague, Dr. Adam Wexler, who is the Director of Systems Architecture at Spacecoin. And before we dive into the questions, so we've got a bunch of questions that we've come up with internally, and we've also got a handful of questions that you, space cadets and audience have submitted. We thought we should learn a bit more about Adam. So I will give a brief overview and sing some of Adam's praises, and then let Adam add in some additional color. Well, Adam is a US citizen. He's traveled and lived all over the world, though. He spent a decade, or the best part of a decade, living in Europe, where he got his PhD in physics in Graz in Austria. And he has worked at a number of the leading space organizations. So he's worked at the European Space Agency, he's worked with NASA, he's worked with the US Air Force, amongst many, many others. And before we convinced Adam to come and join our journey at Spacecoin, Adam actually had his own engineering firm in Florida, where he is still based. His specialty was in thermal engineering, where he was building specialized hardware for satellites and spacecraft. And I think my favorite fact about Adam is that in his younger days, his hair was longer, and he actually saw Nirvana live, which makes me very jealous. They're one of the bands that I wish I had seen in my youth as well. So Adam, any additional points of color you wish to add, or anything you want to grace the audience with in terms of your background before we move on to the questions?
Thanks, Stuart. It's always funny to hear intros because, there are things that you forget you've done. I wasn't even thinking about Nirvana when we started this. So the Seattle music scene in the 90s was definitely one for the record books. And I feel pretty lucky to have been there. Of course, when I was at the University of Washington, I wasn't even thinking about space at that time. I was much more interested in ecology and studying plants and things like that. So I think it's one of the great things about our world is that when you look out to outer space, we don't see a lot of other planets with life on them. I know that there's some discussion around Mars right now, but it's a pretty special place we've got here on Earth. So that's key motivator for me too, is making sure that all is well here on Spaceship Earth.
All right, and we're going to do our bit to hopefully uphold that tradition as well here at Spacecoin. All right. So the first question is, could you share with the community what your role as the Director of Systems Architecture, what does that encompass at Spacecoin?
Yeah, so I think Spacecoin and Space Network as a whole are really trying to bring together a number of different industries, from blockchain technology to the obvious satellite and space technology to communications technologies like 3G, 3GPP technologies. There's a lot to coordinate there. So working with a whole bunch of different types of engineers, from software and blockchain developers to hardcore space hardware engineers, working with all those different folks, they all speak different languages. So, a lot of what I do is run around and try to translate what's happening in one column to what's happening in another column. It's a bit like herding cats, but it's a lot of fun.
And those are three distinct and separate technologies and industries, and it could take a lifetime to master each one individually. So how do you go about, as the technical lead on the project, how do you go about getting expert enough in each one of those to be able to build a cohesive and coherent structure and organization, which can then build a business that runs on top of all three of those pillars?
Yeah, I think it starts from accepting that I'll never really be a master of any of them, and really deferring to and building excellent leadership in each of those different areas, so calling on people who have decades of experience and deep knowledge on those different aspects, and then working together with them to massage a coherent strategy and a coherent understanding of what it is that we're trying to achieve.
And to date, so let's say in the last 18 or so months that you've been personally involved with Spacecoin, what has the biggest challenge been in terms of being able to integrate these three technologies, or to get them to work together? What are some of the hurdles that have been overcome or have to be overcome for this project to be a success in terms of marrying these three different worlds?
Sure. I think the biggest thing is that, each of these different technologies have different cycles to them in terms of time. They have different degrees of oversight and involvement from regulatory aspects, right? So blockchain is, I think, the wildest of the three. It's got a lot of energy, a lot of let's break things and change the world kind of mentality. And so everything in blockchain moves really fast, and it's more of like, hey, let's do this. We can build this and let's just go. Versus telecommunications and space technologies are quite slower, more conservative types of industries. Telecom has a lot of regulations, right? There's many, many different layers of organizations that you have to talk to and coordinate with. And then the space industry itself is undergoing a bit of a renaissance right now. So we're seeing that there's this new space movement where a lot of folks are coming in. There's that same kind of like, hey, let's do something that we haven't done before, largely led by the efforts at SpaceX and Starlink and others who have pioneered the way for commercial space. So it's moving, it's beginning to pick up steam, but really, I think keeping the train together, if you will, where you've got a very fast moving, energetic action in blockchain and the slower, more traditional approach that we see in telecom, and then space somewhere in between the two. So keeping pace and managing that pace, I think, is a big challenge.
And then as you look at, so if we look at the telco world, both in terms of offering, let's say, terrestrial infrastructure for cellular networks and also fiber optic cable for internet, that world is very much monopolized, or it's an oligopoly of a small number of players who control that world, have very deep pockets, it's very expensive. And the promise of space is there that something different could emerge. But what we have seen so far is history repeating itself, in that you have Starlink, very deep pockets, Amazon Kuiper, very deep pockets, some large Chinese constellations, also very deep pockets. And so can you talk a bit about what the opportunity is for smaller nations, how these nations who don't have the budget or technical capabilities to launch their own networks to compete, and how we at Spacecoin are hoping that our technology acts as a foil to this oligopolistic tendencies that tend to happen in infrastructure.
I think it's a good call out that, classically infrastructure, right? So whether it's, AT&T, Bell laying the first telephone lines and telegraph lines, to what's happening now with SpaceX and Starlink, where they're launching, dozens of satellites every other day. There's a large investment and there's a large process that has to happen to begin to lay down the foundations, if you will, of any kind of infrastructure. The promise of space in this is that because we don't have to lay down fiber, or we don't have to necessarily build the basic infrastructure of launch facilities and a space industry, right? Because those things have already begun to form. There's an opportunity now to open up access to the tools that provides satellite communications to a larger audience. It makes sense that Starlink would start out and, have to burn several tens of billions of dollars to sort of forge the way and clear the path for satellite comms. And I mean, they're not alone. We've got Viasat, you've got Globalstar, you've got Iridium, all these other legacy companies that have been doing satcoms for decades now, have all invested billions and billions of dollars to build out that industry. But the result is similar to what we have, I'd say, in a lot of the ordinary, computing devices like smartphones, for example. The tech that's in them required huge amounts of investment. And now we're starting to see that it's much easier for smaller players to take advantage, to have offerings, right? There's lots of different types of mobile providers. There's lots of different manufacturers of phones. So that kind of diversification in the market space is something that I think we're going to start to see now in space. And that's a key place where Space Network is leading the way, right? We're forging ahead with saying, hey, here are tools, here is technology. It doesn't require billions and billions of dollars to get started anymore. And there's the opportunity to cooperate. So smaller nations in various places like Southeast Asia, Africa, South America, places where classically you don't have the kinds of GDP that can support an independent space program. There's now the opportunity to cooperate and to utilize some of this more commercially available technology to join in the satellite communications industry.
And then so down the line, once we push out our network and we have a larger constellation in the sky, why would a crypto head, for want of a better word, why would someone who's very bullish on crypto, why would they want to use a network such as ours, a decentralized satellite network, to manage their crypto transactions, to sign their crypto transactions, to send crypto, as opposed to using either a centralized provider, satellite, or terrestrial?
I think this comes down into network architecture type questions. But one of the things that we do have the opportunity to do with satellites on orbit is we can optimize the routing. So, latency and speed can be a very big reason for that. Furthermore, as the constellation gets deployed, there'll be the opportunity for different participants to establish their own rates for how transactions flow over their node. Let's say you and I are two different participants providing our own satellites to the network. And let's say that I optimized my satellite to be very, very fast and I charge a premium for that. Whereas you said, you know what, I'm going to go for volume and I'm going to do a slightly lower rate, but everyone's going to suffer a little bit in terms of speed. And so what that means is that depending on how I write my contract or how I want my transaction to be sent, either costing me less in gas fees or just getting there quicker, the network will help optimize. So I think that's a big reason for why this is an interesting play. I think the other side is that, we do have the ability to do more point-to-point transmissions. So as the network gets put on orbit, we will see that we'll increase the number of inter-satellite links. That will help also with speed and reduction in latency. And then I think the last piece really is that we do a lot of heavy encryption on all of our nodes. So since we control the standards that go into the space network protocols that underpin Spacecoin, there's a very high degree of security inherent in the transactions.
Yeah, and I think it's worth also saying that if a transaction is occurring between two users passing just through a decentralized satellite network such as ours, that signal and that data never has to touch terrestrial ground stations. It never has to be recorded or listened upon by other software or other actors, bad actors in an ecosystem. So I think there is a world where that transaction is inherently more secure going through a decentralized satellite network such as ours.
Yeah, in a way, there's sort of baked in at the foundational level, there's the ability to really strictly control how your data moves through the network. And, that added security is something that when you do transactions over the public internet becomes a little bit harder to do, right? Where does your traffic really go? And I think, as we're seeing in a lot of regions around the world now, there's more awareness and more concern around, dummy nodes being set up, interceptive messages, and, even blocking of messages. So I think something about this technology that's really nice is it allows us to have a system that is more resilient against tampering, censorship, and those types of interference. So
yeah, and I think if we project forward a few years where we have our own satellite constellation, but we also have our protocol running on other satellites, so we have a much larger constellation than just the satellites that we have launched, there is the opportunity for users to specify how their data gets routed through those satellites, which participants are allowed to handle their data based on reputational scores, based on the price of that data throughput, based on location or the underlying, let's say, location of the owner of that asset. So there really starts to become a world where you can protect your data to a much more granular level than is currently possible today. When your data flows terrestrially, you don't really have any say, or even if it flows through another satellite network today, you don't have any say where that data goes, where it's downlinked, into which countries, into which jurisdictions, who's storing it where. That's another one of the benefits.
Yeah, no, indeed. And I mean, that piece that you mentioned there at the end is, I think, really interesting, which is the data sovereignty play. And, we are seeing more and more nations codify data sovereignty in law. So, for example, Saudi Arabia has already done this. Others are following suit. And I think that that's something that's really critical, not just for companies, startups like ourselves who are, coming in and looking at that shift towards more sovereign control over the data of citizens, but larger players like Google and even Starlink, are having to tackle this and wrestle with the arrangements that need to be made to honor these lawful requests. So it's an interesting time. And I do think that this is a place where decentralization and the tools that go into making decentralized networks operate will really have an advantage over the more monolithic centralized systems like we see with, for example, Starlink.
And related to security, actually, one of the questions from the community comes from Mr. X, who has written or has asked, what encryption or privacy methods are we using to protect user data within the Spacecoin network?
There's a lot of different layers of security and encryption going on. I can say that all of our satellite links are encrypted with, standard military encryption grade stuff. So I don't want to give away too many secrets.
Yeah.
But I'll say this, that, like everyone who's working in this field, whether it's crypto or blockchain technology in general, or even satellite communications, we're all very, very aware of the challenges that are coming and that are already inbound from, let's say, quantum computing. So our encryption algorithms and our encryption protocols are really designed around a post-quantum encryption world. So we're rolling with the best right now in terms of what's required for security, keeping up with things like CMMC. And as that field evolves and continues to evolve, we have the ability to adapt and update our security protocols. So obviously security is absolutely critical to the integrity of the network, as well as to the value of Spacecoin, and most importantly to the integrity of our users' data. So it's AES 256 and all those types of standard tools are utilized, but how we implement them and the ways that we keep those keys fresh and we keep that data protected, that's the secret sauce.
And then another question from a user 0x_TD. So they have a question which relates to reliability, and I'll add on, let's say, resiliency. So can we talk a bit about how having a decentralized network helps the network become more reliable and resilient versus either a centralized network or a terrestrial network?
Sure. So resiliency is always an interesting one for networks, right? And I think one of the key pieces that a decentralized network and the network that we're working to foster has going for it is that you don't have a single point of failure. So if something were to happen and, SpaceX or Kuiper or somebody, which they're U.S. corporations, the government could come down and say, hey, we don't like what you're doing and we're turning it off. That's it. That network will go down. With our system, because we're looking to partner with multiple different nations and multiple different partners from around the world, we kind of already begin to break down that problem of a single point of failure. If South Africa launches 1,000 satellites and Colombia launches 1,000 satellites and Sri Lanka launches 1,000 satellites, well, everyone can cooperate from having those satellites in orbit and sharing data and allowing the network to function. If something happens in one of those places where they no longer have the opportunity to operate, the rest of the network can take over that operation. So there's no single point of failure. I think that's probably one of the biggest benefits in terms of supporting resiliency. I think the other thing that plays into it, and it's a similar type of piece, is that by providing the open standards that will allow for this network to be launched into orbit, we are creating an ecosystem of providers throughout the global supply chain. That means that, if something happens in one geopolitical region or another that might disrupt supply chain or might impact the ability to manufacture, other regions of the world can continue to pick up that slack. So there's another piece of resiliency. So now we've got, let's say operational resiliency, and then we've got the ability for that supply chain resiliency, I think, which all of us are very aware is a significant risk in the world today.
Interesting topic related to this, which you mentioned, was the way that satellite networks operate today is that each satellite operator has a proprietary network. So Starlink network will be proprietary, Amazon's will be proprietary, SES will be proprietary, and so on and so forth. And none of them can communicate to each other. And so you end up building, to build a satellite constellation that has any value, it requires, or for at least for real-time communications in low Earth orbit, which is where we are operating, requires hundreds, if not thousands of satellites. And that is very difficult for most companies or nation states, even nation states, to do. Hence why so few companies have made that or been able to do that successfully. By having a decentralized protocol such as ours, you end up with a system which is much more interoperable, where companies, they might be telecoms companies, they might be IoT companies who do some sort of monitoring, they might be nation states who want some level of communication sovereignty, and so on and so forth. They can all write and connect to a protocol, to a standard, and then they can all share their resources. So as Adam mentioned, maybe a a smaller island nation maybe only has 10 satellites that they can pay for or launch. But if they're part of a decentralized network, which consists of 10,000 satellites, they get the benefits of an entire network without needing to put up all of the capex and the opex to run that network. And so that's a message which is resonating very well with some of the smaller countries and developing nations that we speak with, because they know that they don't have either the technical capacity or the financial capacity to launch 7,000 of their own satellites to serve their own home nation. But by launching a small number, they can take part in a global constellation. They can have a level of data sovereignty. They can monetize their assets over different jurisdictions and geographies. And that's something which is getting a lot of interest from the people we speak with.
Yeah, indeed. And I think you hit on a lot of really critical pieces in there, and I do think that the big one being that you don't need to have to put up a large investment to make participation in the network possible. And, if we're talking about LEO satellites, they're only up there for 5 years, 7 years, maybe. So you're constantly having to replenish them to maintain the network's integrity. And so, that's a big bill if you're just a small nation somewhere. But because there's the opportunity, thanks to the Space Network Protocol and because of Spacecoin, for all of these smaller players to cooperate, it lightens that burden of not just, the capex to launch the constellation, but, the ongoing investment that's required to upgrade technology, to keep up with the latest communication standards, to address concerns and issues that may arise during operation. I mean, solar flares are a beautiful thing because they make aurora and it's really beautiful to watch at night, but they are death to satellites. So, as much as I enjoy solar weather and things like that, it does worry me as a satellite operator. And that's something that always is there. It's always a risk. Starlink has to face it. I mean, they've lost whole batches of satellites because of bad timing on solar flares erupting during deployment. And so having that shared basket of risk and the shared reward, I think, goes a long way towards building a more stable global community as well.
Yep. And so the next question from a community member, Yoru Bad Boy, asks, how do we handle updates or maintenance on the satellites once they are in orbit?
You can get one at spaceladder.com. No, I mean, that's one of the big challenges is once they're up there, they're up there. We can do software updates. We do regular maintenance from the software and operational side. But once the satellites are launched, they're up there. There are efforts ongoing within the larger community to perform on-orbit servicing, which for some birds would be adding fuel, for example, so that they can continue to orbit correct and live longer periods of time. But in general, once we've launched a system, that's it. That's the configuration it's in, and it's going to be in that configuration for its duration. And like I said, most LEO satellites last about 5 years. So
yeah, and actually, it's probably worth commenting on that point that the average satellite in low Earth orbit lasts around 5 years. And so although Starlink have at the moment, I think that the figures reported to be 7,000 to 8,000 satellites live up in the sky at the moment, and they have plans for many, many more. Those 7,000 to 8,000 satellites, if we fast forward 5 years, if they weren't to be replenished, would fall back down to zero. So they have a lead on the market. It's not like the terrestrial world where you lay fiber optic cable and it maybe has a lifespan until it's replaced by a superior technology. This technology will naturally deorbit at roughly 5 years, plus or minus a couple of years. And so SpaceX and Starlink will have to keep replenishing those satellites. So although they have a lead on the market today, fast forward 5 years, that lead gets eroded away and they have to keep continually replenishing that constellation.
Yeah, indeed. And I mean, we tend to forget, but a lot of the fiber optic cable that we are all enjoying the benefit of was laid back in the 90s. So back when I was jamming out with longer hair to Kurt Cobain and his band, they were out there digging holes and laying down fiber that we are just starting to use now. That is a very big difference between terrestrial infrastructure and orbital infrastructure, is that, everything on orbit has a short lifespan. Some systems can be up there for more than a decade or two, but they are extremely expensive and very purpose-built types of platforms. What we're seeing in the new space industry with LEO satellites is that, we're moving towards what I call flying laptops. So more mass-produced type, large deployment capable pieces of hardware that the unit cost begins to fall to the point where, well, if we lose a batch, it's not that big of a deal. Starlink is looking to double their constellation deployment size in very short order. They're heading towards a new launch of satellites every day and a half. By the end of this year, they should be on pace for that. They've continued to increase the pace of deployment. And at the same time, we know that there's about 1 to 2 Starlink satellites deorbiting every day. And that number will continue to grow as the constellation ages out.
Yeah. And I think it's also worth mentioning, not to scare the audience, that although these satellites are going to be replenished every 5 years, as Adam mentioned, the cost to produce and manufacture a satellite and the cost to launch satellites are falling precipitously. So if you just look at a cost decline curve for launch costs, for satellite manufacturing costs, they are falling very, very rapidly. And so over the longer arc, that cost becomes much less of a concern, and the payback on these satellites becomes very, very attractive from an IRR and an ROI perspective. And then the other thing, which is also worth mentioning, is that related to that, it ties into plans and our strategy to not become the sole provider of satellites into our constellation, and more to start by launching a constellation, but to provide, more importantly, the protocol layer for other satellites to interoperate and to use our software and our technology on their satellites as well. And that's where Spacecoin comes in. And we would love any satellite provider out there. They could be, eventually it would be incredible if one of the larger players like an Amazon or a Starlink wanted to also incorporate our software technology into their satellites, as it's also a way for them to earn more revenue and so on and so forth. That's also part of our strategy to focus not just on building hardware, which is what Adam's focused on, but we also have a full telecoms team as well, who are focused on building telecom software, and the blockchain team, which are focused on building the protocol. And these things all combined together give us multiple opportunities to create a business and create a moat, and to have a business which is an ongoing concern and also rewards participants such as you and our community by being early investors and believers in Spacecoin and what we're building here.
Yeah, indeed. And I think, that's where we are in this sort of cost reduction curve. We're really starting to see the increase in the pace of that. At the start of the Apollo program, there was the cost of a single transistor was tens of thousands of dollars. By the end of that program, it was tens of cents. So in a similar way, because there's so much activity ongoing to bring satellite technology into a truly commercial space, we are seeing that the cost is falling precipitously. And that's largely driven by competition, but it's also driven by a lot of innovation and a lot of that, kind of like, hey, we can do this differently kind of spirit. And we're seeing that there are now more launch providers coming into the market space, more satellite builders coming into the market space. So we're moving away, if you will, from, let's say, the more classical defense contractors and primes that have been used to, multi-billion-dollar contracts, to teams of people and companies that are more focused on how can we do this and what is essential for this deployment in low Earth orbit, right? Because low Earth orbit is a very different kind of environment than, say, geostationary orbit, where you're much more exposed to space weather, much more exposed to the harsh environments of space. Close to Earth, it's still a little bit better than out there. But this means that cost drops, accessibility improves. And, like you said, the goal of the whole space network protocol is to make this an open architecture so that we can have a heterogeneous network where, if somebody like a Starlink wanted to join and start utilizing the protocol, why not? We can take advantage of each other's hardware in space and really, share the spectrum.
Yep.